Alright, Math 3, Logarithmic Functions 2.1. So, it says graph each function over the domain -4 to 4. Okay, so easiest thing to do would be to make a table from -4, -3, -2, -1, 0, 1, 2, 3, and 4. Okay, so 2 to the -4, that would be like 1 over 2 to the 4th because it's negative and makes it a fraction. So 2 to the 4th is 2 times 2 times 2 times 2. So that'd be 4, 8, 16. So we'd have 1 over 16, very small number. Okay. Now, because this is exponential, remember our pattern here is we're timesing by 2. So I could keep plugging numbers in, or I could just times by 2, which would give me 1 over 8, and then 1 over 4, and then 1 over 2, then 1, then 2, 4, 8, 16. Okay? Because we're timesing by 2 each time. So then we graph that. So -4 and 1/16 would be really small. -3 1/8 still small. 1/4 still small. 1/2 a little better, and then 1. And then at 1 we jump up to 2. That was a little off there. Oh, dang it. Huh. Somehow I erased all those dots. So that was at 1, then 2, then 4, then 8, and then finally 16. And then 1/2, and so on. And remember, it has an asymptote because it's exponential, so it'd look like that. Okay, now let's do this one. Okay, and if you recall, when you're dealing with exponentials, the format is y equals a times b to the x. So a is the y-intercept, b is what you times by. So that would tell me 2 is our y-intercept. So as I go to the right, I'm timesing by 2, so then it would be 4. And then at 2, it would be 8. And at 3, we'd have 16. And then at 4, it would be at like 32. And going to the left, we'd go down to 1, then 1/2, and so on. And it would look very similar like that. Okay? Then 3 is 1/2. Okay? So if I go 1/2 to the -4, that's actually 2 to the 4th. So it ends up just being backwards. And we'd end up with 2 to the 0 would be 1. And as I go left, it would get bigger, and as I go right, it would get smaller. It's hard to get these dots just right. And it looks something like this. 1 here, 2, 1/2, 1/4, 1/8, 1/16. To the left at -1 would be 2, -2 would be 4, then 8 at -3, and 16. So it looks something like this. Okay. Then on number 4, same idea. Our y-intercept would be 2, and we're timesing by 1/2. So 2 times 1/2 is 1. And then 1/2, and then 1/4, and then 1/8. To the left, we'd already go up to 4, then 8, because we're dividing by 1/2, which is the same as timesing by 2, and it'd come up like that. That wasn't a very good drawing of it. Okay. Then 5 says compare graph number 1 to number 2. It says multiplying by 2 should generate a dilation of the graph. Dilation is basically just making it bigger. But it looks like it's been translated vertically. How do you explain that? Well, if we think about this, 2 to the x is just 2 times 2 times 2 times 2. Starting out by timesing it by 2, one extra one just shifted it, essentially. Okay, vertically, or you could even say it shifted it back by 2. Okay, it's probably the best way you can explain it. So, 6 says compare 3 and 4. Is that still valid? Well, yeah, because even though we're dealing with 1/2, it's like it's shifted it the opposite way, isn't it? Okay, that same kind of concept. Alright, now 7 through 11 says we're looking at these logarithms. We want to put them in numerical order from smallest to largest without using a calculator. Okay, now you should remember this, that logarithms are inverses of exponentials. So if I give you this exponential y equals b to the x, its inverse is going to be the log base b of y equals x. So what I would suggest doing with these is translating them as an exponential to try to help you understand them a little better. Okay, so I could go, the y would be like 32, so 32 would equal 2 down here would be the base, so 2, and then it's like this is equal to x, we're kind of imagining. We'll put question mark. Okay, now this one would be 343 equals 7 to the question mark, then 1 equals 35 to the question mark, then 225 equals 15 to the question mark, and finally 11 equals 11 to the question mark. And I'll see what you know. This one should be easy to see because it's one of those rules. Anytime anything to a power equals 1, it means that power is 0. Okay, so that x is what it would be equal to, so the log base 35 of 1 would be 0. Okay, this one should be easy. Another easy one, that would be 1, because 11 to the first is equal to 11. Okay, now 15 to the what power is 225? If you don't know that, you should. It's 2. 15 squared is 225. Now 343 to the 7th, if you didn't know, go 7 times 7, which is 49, times that by 7, which is 3, 6, 28, plus 6 is 34. So that would be 3. And then 2, to get to 32, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So it's 1, 2, 3, 4, 5. So least to greatest would be C, E, D, B, and A. Okay, so that's kind of what we're looking at doing here. So kind of tedious, but let's get going. So this one would be 81 equals 3 to what power? 125 equals 5 to what power? 8 equals 8 to what power? 1 equals 4 to what power? And then when there's no base here, that's called the base 10. So it'd be 100 equals 10 to what power? It's the one you use most commonly, so often they won't even put the base there because they don't need to see it. So we should know that one. That would be 2. This one, once again, would be 0. This one would be 1. Those should be easy ones to tell. 125, 5 squared is 25, so 25 times 5 would give you 125, so that would be 3. And then 3 to what power would give us 81? Well, 3 times 3 is 9, times 3 is 27, times 3 is 81, so it would be 4. So lowest would be this one, then this, then that, then B, then A. Okay. Now let's take a look at number 9. So we'd go 45 equals 7 to what power? 12 equals 3 to what power? 12 equals 4 to what power? 30 equals 3 to what power? And x equals x to what power? Okay, this one should be easy. Once again, that's 1. Okay, but these other ones are going to be trickier, right? Because we know 7 times 7 is 49. So that would be 7 squared. So this one has to be close to 2 to get 45. So it would be 1.8 or something high like that. Okay, now this one, 3 squared is 9. 12 is higher than 9. So it'd be like, what, 3.1, 3.2? And now you're not supposed to check these with a calculator. So we're not looking for exact numbers, but just trying to estimate. Okay? 4 squared would give us 16. So this is going to be, less than 16, kind of similar to this one. Okay, 1 point some number. Not sure what it would be. I think this one is smaller than this one, though. Okay, then 3 to the third is 27, so that would be a little bit higher than this one, which I think if we looked at it, we'd go here for first. It's our smallest. Then I would probably go this as my next, then here, then here, and then here. Okay, those ones are trickier to figure out. Okay, now we've got some fractions, but I treat it the same way. 1 over x squared equals x to what power? 1 over 5 equals 5 to what power? 1 over 8 equals 2 to what power? 1 over 10,000 equals, once again, no 10, but we know it's 10 to what power? And this one, 1 equals x to what power? Once again, we should know this one's 0. Okay, now these ones, okay, how could x squared be x squared? Well, it'd have to be a 2, right? To make it a fraction, it would be negative. So 5 to become 5 would be 5 to the first. We make it negative because it's a fraction. 2 to get to 8 would be 2 cubed, but 1 over 8 would be 2 to the negative 3. And then 10 to the 10,000 would be cubed again. Or would it be, no, it could be to the fourth and a negative, right? 10 times 10 is 100. Times 10 is 1,000, so yeah, to the fourth. So now our smallest is negative 4, negative 3, negative 2, negative 1, and then finally 0. Okay, last one of those. Alright, so these are all these first two are log base 10. Okay, so it would be 200 equals 10 to what power? 0.02 equals 10 to what power? Okay, then 10 equals 2 to what power? 1/10 equals 2 to what power? And then finally, 200 equals 2 to what power? So once again, trying to make you think. So we know 10 squared is 100. How do we get 200? Well, that would be a little bit past because 10 cubed is 1,000. So, I don't know, maybe like 2.2 maybe. Now, 0.02, that is like 2 over 100s, 2 100ths. Okay? So to get that to be the bottom, to be the 100, would be a 2, but that would be a negative 2, so it would be like a negative 2 point something. Okay? Same with these ones. Notice they're the same. One is just a fraction, so this would be the negative version. Now 2 squared is 4, 2 cubed is 8, so it would be like 2.3 point something, 3 point some number. And this would be the negative 3 point some number. I don't know if it's 8. I'm just writing 8 because I wanted to. And then 2 to what power would be 200? Well, that's going to be pretty big, right? Because if we're multiplying by 2's to get somewhere, it takes a while. So 2 times 2 is 4, times 2 is 8, 16, 32, 64. Okay, so definitely the biggest. So smallest would probably be the negative 3 something, then the negative 2 something, positive 2 something, positive 3 something, and then whatever that one would end up being. Something like that. Okay? Alright, so next question. Is it possible for a logarithm to equal a negative number? So could the log base of some number equal a negative number? Okay, well, flip it around. Can we have b to the negative x equaling a number? Yeah, we can. We saw up there multiple times we had negative numbers, so yes. Okay, that. Is it possible for a logarithm to equal 0? Well, that would be like b to the 0 would equal something. Yeah, it would always equal 1. We saw a few of those. Just one instance would be that one right there. Okay, now does log base x of 0 have an answer? So can I go x to a power equals 0? Okay, that cannot happen. Because you can never have this right here. Okay, there's no power that you give x that will make it equal to 0. Does log x of 1 have an answer? So 1 equals x to some power. Yeah, it does. We already talked about those. That's like this one, right? That'll equal 0. Because anything to the 0 power equals 1. What about this one? So we'd have x to a power. Can it equal x to the 5th? Yeah, because that could be 5. So yeah, it could. Okay. Alright, let's take a look at the last ones. Now this is just kind of reminding ourselves of some properties of exponents. So remember, anything to the 0 is 1. So negative 6 to the 0 is 1 times 11 would give us 11. Negative 3 to the negative 2, okay, so that would be 1 over negative 3 squared, which would be 1 over 9. 4 to the negative 3 would be 1 over 4 cubed, which 4 cubed is 64. 1 over 64. Okay, that 2 to the negative 1 would bring it up, and you'd have 9 times 2 to the first, which would be 18. 8 to the 0 would be 1. 4 cubed is 64. 64 over 1 is 64. 23, 4 to the 0 is 1. Then you'd bump up that to be 2 to the 5th. 2 to the 5th is 32, did we decide? Okay, this whole fraction doesn't matter what happens on the inside because it's all being raised to the 0, so it's 3 times 1, which is 3. Okay, that 0 turns it into 1. 6 to the negative 4, we'd have 42 over 6 to the positive 4. 6 to the 4th would be, that's a big one. Let's actually do this. Remember rationals? 42 is like 6 times 7. 6 to the 4th is like 6 times 6 times 6. Those 6's cancel. I forgot a 6. So it's really 7 over 3 6's. 6 times 6 is 36. Times that by 6. And we get 216. So it would be 7 over 216. Okay. 26. 6 to the first would bump it up because it's a negative 1. So 3 times 6 to the first would be 18. This one, a negative on bottom, would shoot that up top, and this one down low. So it would be 4 to the first over 7 squared, which would be 4 over 49. And finally, that would happen the same thing, so we'd have 4 to the first over 32 to the first, because the negative on top makes it on the bottom, negative on bottom makes it on top. So 4 over 32 would reduce to 1 over 8. Okay, there we go, guys.